Alright, so cone's pyramid with a circular base. So the way we work out the volume is the same as for any other pyramid. Whatever the shape of the base, it's 1/3 of the volume of a prism with the same height and the same base. Right? So that's the way that we think about it. We use cones all the time. Obviously, ice cream cones, or cones of physics, with quite a solid sort of structure. It's quite handy in many contexts. The volume of a cone, V equals 1/3 pi r squared, which is the area of the base, times h, which is the perpendicular height. Okay? So V is the volume that we're looking for, r is the radius of the circle on the base, and h is the perpendicular height. Right? So V equals 1/3 pi r squared h. Now the volume of a cylinder is just pi r squared h. This is just 1/3 of it. Okay, so if we got a cylinder, we've got a cone with the same base and same height, and we poured water into it, we find that 3 of them would fit in. Okay? That's the way that would work. V equals 1/3. So we'll do a couple of examples in a sec once we bring that down. Right. So I'll just go up to here. So here we have a cone, the height is 30 millimeters, and the diameter is 18. What's the radius? Chris, what's the radius of this circle? 9. Good. So R is equal to 9. Going up. Okay. So if I move it back up, somehow it doesn't seem to like when it changed. Okay, so the radius, R is equal to 9 millimeters. And the H, the height of this is 30. Alright, so we have the parts that we need to work out its volume. So we say V equals 1/3 times pi times the radius squared, which is 9 squared, times the height, which is 30. Okay, can you find it? Two five four four. 2544.69 millimeters cubic millimeters. Alright, so we're just plugging it in and saying 1/3 pi times the radius squared, which that's the area of the bottom, times 30, which is the height. Alright? Give a chance to just write that down. Now sometimes you might be given the slant height instead of the perpendicular height. And if you're given the slanted height, we need to find the perpendicular height somehow. What are we going to use to find the perpendicular height? Pythagoras' theorem. Okay, because we can have a right angle triangle inside the cone, and we use that to find the unknown side, which is the height. Okay? There you are, it's alright. We'll just go through this. Is that okay? Alright, so this one, we've got 44 is the diameter, and 35 meters is the slant height. So what I can do is, first I'd like to say, we'll use Pythagoras' theorem. To find perpendicular height. Right, so we need to find the perpendicular height using Pythagoras' theorem. So I'm going to draw the triangle. So I've got, that's right angle, so I've got the slanted height, which is 35, and that's the hypotenuse. What's this length here? So I imagine it like this, I'm going down from the center. That's my triangle here. So what's this short length here? And what's this short length? 22, which is half of 44. 22. So we have 22, 35, and let's call this one h because we want to find the perpendicular height. So what is Pythagoras' theorem, Adrian? Yeah, so h squared is equal to 35 squared minus 22 squared. And 35 squared minus 22 squared is what? 35 squared minus 22 squared. What is it? 741. And the square root of that is? What's the square root of 741? 27.2. Okay, 27.2 meters. So we're up to the point where we've got the measurement we need. So we can say that that's 27.2 meters. Now I've got all that we need to find the volume. So what I have to do is V equals 1/3 times pi times the radius squared. What's the radius squared? What's the radius? 22. Good. So times 22 squared. And then we times it by the height, which we just found, which is 27.2 meters. Please, could you find that, please? 1/3 times pi times 22 squared times 27.2. $17,786.15. Good. Good. And that's cubic meters. So that's the volume. Alright, so it holds quite a lot of stuff. Imagine if this was a big tank or something, a cone-shaped tank on top of a huge pylon, this would be a massive thing. It would be 44 meters across, that'd be normal. Right? So it holds a lot of whatever you want to hold. Water, cordial, whatever you like. Alright, so you notice the two steps. And this is what I need to highlight to you. Thinking about strategies for solving problems when we approach it. It's like we're thinking about surface area. Right, you're given a cone, you're given a shape. You think, what information do I need to know about? I need to know the radius, I need to know the height. Do I have the height? No. How can I find it? So then you have to use Pythagoras' theorem to find what the height is. Once you find that, then you can use the formula to find its volume. Okay, so it's really about breaking down these problems into step by step that you can then approach them. Right? Using strategies to break up problems into smaller sections that you can tackle. Alright? We'll come back to this, I'll just leave it at that. Now this is a different sort of question. It says a cone has a volume of 160 cubic centimeters and a height of 15 centimeters. Okay? What is the radius of the base circle? So this is about using the formula in a different way. So what do we know about the formula? Well, we know that V is equal to what? V is 160. Okay? And I know that H is what? What's H? 15. H is 15. And I want to find R. That's what I'm looking for. I'm I'm looking for the radius, I'm looking for r. So then I put this into the formula. I say, well, 160 is equal to pi times r squared times 15. Alright, so now I've substituted in the values I know into the formula. So now 160, I know pi, r is what I'm looking for. Now the question is, how do I get this r squared on its own? Divided by what? What do I want to divide? So right now I've got 15 and pi multiplied by r squared. How do I get it on its own? Divide by 15 and pi. Alright, so I'll do it one at a time. I'll just continue up here. Alright, so if I do it, I'll divide it first by 15. Okay, divide by 15. So we've got 160 divided by 15 equals, and these 15's cancel out. So I get pi r squared. What's 160 divided by 15? 10.6. 10.7 equals pi r squared. And then I want to get rid of the pi. So what do I have to divide it by? Divide both sides by pi. So I get r squared on this side equals, what's 10.7 divided by pi? 10.7 divided by pi. Tells us this time for us. Let's say 3.4 is fine. And the final thing, I've got r squared here. How do I undo a square? What's the thing you do to undo a square? That's undo a cube. Close. The square root. Yep. So square root both sides. So r equals the square root of 3.4. And that's equal to, what's the radius equal to? Square root of 3.4. So 1.8 to 1 decimal place. Okay, so we can answer the question. The radius is approximately 1.8 centimeters long. Okay, so that's the length of the radius. It's approximately 1.8. So again, it's about recognizing what information you have, and then substituting that into the formula, and then rearranging using some equation techniques that we've learned before to find out what the radius is. So exercise 2.07, question 1 to 6, just part A and part C, and then questions 7 and 8. Alright, you should have plenty of time to do this.